All right. Welcome, folks, to our workshop on project-based learning. The way we're going to run this is that our three panelists will talk for a little bit about their own experiences, really focusing on, what they've been up to, but then lessons learned, things that other folks could take into the project-based learning that they're trying to advise. And you may say that our title is on the vague side, but we are trying to make it really broad because one of the lovely things you'll find when listening to our panelists is really how variable, like open-ended statistics and data science work can be with undergrads. And so, we're going to hear about things that are maybe more of the consulting end or the classroom end or the research end, but all can sort of get our students authentically interacting with data, which is great. Donna and I are going to be the moderators. Geez, Donna, I'm introducing the panelists, but I'm not introducing us. So maybe let's just very briefly introduce ourselves, and then I'll introduce our lovely panelists. So I'm Kelly McConville. I teach at Harvard, and I'm a big fan of getting the students to think about sort of the whole cycle of data, right? Like sort of the start to the end of the data analysis process. Donna, who are you?
I'm Donna Lalonde, and I'm at the American Statistical Association, but I have to say, I'm definitely a recovering academic. And so anytime that I can spend time with colleagues talking about teaching and learning, it makes my day. So really excited to listen and learn.
Great. All right, so let's hop on into this. So I guess I said that our panelists will give us a short presentation, but then really we do want to make sure there's plenty of time for questions. So as they're talking, feel free to put questions in the chat. We'll also call on folks at the end too. So there's going to be lots of time for questions. So get generating them as our panelists are speaking. Okay, so let me now introduce our three panelists. I'll start with Emily Griffith, who is an associate professor of the practice in the Department of Statistics at NC State and director of the consulting at their Data Science Academy. Her research interests include developing best practices for teaching statistical consulting and collaboration. She's active in the North Carolina chapter of the ASA and served as its president in 2019 and is currently the District 5 Vice Chair to the Council of Chapters Governing Board. Wow, that's a little bit of a mouthful. She is the recipient of the Dr. Dennis Bose Citizenship Award and a fellow of the ASA. In her spare time, she enjoys spending time with her family, especially when this involves watching basketball, which to me makes sense being in the research triangle.
Baseball.
Oh, baseball? Oh, that makes less sense. Is there good baseball in the research triangle?
Yeah, we have the Durham Bulls.
Okay, all right.
Minor league, which is maybe the best baseball.
Oh, okay. Fair. When I lived in Walla Walla, we had the Walla Walla Suites, and that was probably the last time I went to a baseball game, though, I guess I'll admit. Okay, our second panelist is Nick Horton, who's a professor of statistics and data science at Amherst College. He's author of 4 books about data science and statistics in R. He was the co-chair of the National Academies of Science, Engineering, and Medicine's Committee on Applied and Theoretical Statistics. He's a recipient of many awards, including the ASA Founders Award for Distinguished Service, and is a fellow of the ASA and the, is it AAAS? Is that how people usually say it shortly? Okay. He is currently the editor of the Journal of Statistics and Data Science Education. In his spare time, not seeing basketball or baseball, but he enjoys exploring rail trails and hiking. He was one of the founders of the Friends of Northampton Trails, an organization devoted to supporting the expanding network of rail trails in Northampton. Okay, and last but not least, we have Mark Daniel Ward, who is a professor of statistics and by courtesy of agriculture and biological engineering, computer science, mathematics, and public policy at Purdue. I feel like there's a couple of departments maybe missing from that list, but you still have time, Mark. His research is in probabilistic, combinatorial, and analytic techniques for the analysis of algorithms and data structures. He currently serves as director of the Data Mine and interim director of the Integrative Data Science Initiative. He is also the PI on the National Data Mine Project, or Data Mine Network Project, which we're going to hear about, funded by a grant from the NSF to the ASA. He is the recipient of the Mu Sigma Rho William D. Ward Statistics Education Award and is a fellow of the ASA. All right, what does Mark like in his spare time? In his spare time, he enjoys camping with his family. All right, those are our wonderful panelists. I'm going to hand the mic now over to Emily.
Great, thank you so much. I was really excited to get to be here today. I absolutely love the class that I'm going to talk about. And I'm jealous that you're going to go camping with your family in 1 hour, Mark. All right, so I'm going to talk about teaching a collaborative undergrad practicum, but in a large statistics department. So if you could go to the next slide, that would be great. Yeah, okay, so the first thing is just, and I'm sure that all of you know this, but undergraduate research is a high impact practice. And one of the issues that we run into in a program as large as ours, we have about 300 undergraduate majors, and it might actually be a little bit larger than that right now, is that it's really hard to find a substantive project for each student, and it's very hard to find a faculty advisor for each student, because it takes a lot of time to do undergrad research well, and we have a large number of faculty, but not enough for 300 projects. We do, as a department, though, have a goal for getting every student some sort of experience that is outside the classroom. And that can be an internship or research experience. And it can be in the statistics department, or some of our students are sort of embedded in labs across campus. So anything like that is what we're looking for. So I'm calling our class a partial solution, because we have not solved the entire problem, but we have created an interdisciplinary, cross-administrative, and I'll explain what that means in a second, undergraduate project-based research course by partnering with campus data stewards. So we send out a call for applications to this class, where students have to write about the classes they've taken, why they're interested in this particular topics that we're going to cover, and we weight the admissions actually towards students without other experience. Because if you've had like 15 internships, you don't need us. You're doing fine. But this is an interdisciplinary class because it's taught by me and a friend of mine who is also a colleague. She's actually left NC State and went to Lenovo, but has continued to teach the class. But she's a social scientist. And it's cross-administrative because we work with several different groups on campus with campus data. So our students get to analyze real data from students like them. So next slide, please. So one of the benefits of working with a social scientist whose expertise is in assessment is that we have this beautiful map for the core areas that we address. And so what we try to cover in the class is a mix of domain knowledge, so getting them to actually apply the statistical concepts they know. A lot of times they do a logistic regression analysis, which is something new for the students. And so getting to learn how to kind of self-teach an extension of a technique that they know from a sort of a regular regression model to a logistic regression. We talk a lot about research design. We have them reflect on their positionality, to learn how to document their work, to keep a research journal, to really structure the process and think in depth about what a good research question is. We also emphasize communication skills. The students give oral presentations both to the data stewards, and they're required to present at the undergrad research symposium with a poster. They get to meet with the data stewards at the beginning of the semester and ask questions. They do multiple presentations in class, updating people on what they're working on and how it's going. And they also write an executive summary, an abstract, and 2 literature reviews during the semester. They do all of this in groups, so teamwork is part of that, and we have them create and sign a teamwork contract about how they're going to work together. hoping that that helps them develop a little bit more advanced problem solving skills. We also work on professional development. We have them practice talking about their projects in like a hypothetical job interview, and learning how to do that. And then maybe the most satisfying part is that we have these campus partners who work with the class. And so they all have like a wish list of analyses, like things that they're interested in that they don't have time to do. And then we do that work, not all of it, but some of it during the semester. The students learn about different programs on campus that they didn't know about. We've been doing some work with grad student data, so they've gotten to learn how grad school works. In a way that is different from what most undergrads know. And then they get to know people on campus who are really involved in aspects of the student experience that they haven't necessarily thought about before. So it's a really enriching experience. Next slide, please. So for the lessons learned and any next steps. So the first thing is that the bulk of the work is really organizing and supervising the class. So if we call it a little faculty retreat, there's only 2 of us, but we meet for a solid 8 hours before the semester, generally in one go, to map out the semester, to make sure we have data for the projects, to mark out the deadlines, to figure out when the undergrad research symposium is and when we need to print the posters, and then kind of work back from there. Because you have to really be involved in each group, a smaller class size is better. We went up to 21 during COVID because students were having a hard time getting internships, and we have taken it back down to 16, which is much better. We also have found that it's really helpful for the students to map the course activities to the learning outcomes and be very clear about that with them. So why are we asking you to reflect on something? Why are we thinking about positionality, and some of those ideas? Another thing that just makes it easier is if you can establish a pipeline for research projects. It's so much better from a time-saving perspective to be able to go back to a set of campus data stewards and say, do you have anything else for us? And then they can give you something instead of trying to like find something new that's going to be substantive, that has data that we can access and share in different ways. We also have a great textbook. It's a newer book. It's called The Indispensable Guide to Undergraduate Research. And it is just a lovely read. I actually read the first one at a baseball practice, and the whole book through at one practice. So it's not very long, but it has questions, it has personal stories in it, and it's just a really good book. And the students all say they wish they had it earlier in their careers. And then the last sort of big success I think that we've had is that this idea that teamwork makes the dream work, right? And so co-teaching makes the course a much richer experience. It's not just my opinions and experiences. We also have started using a lot of campus resources. So we have the libraries come talk about stuff. We have the Office of Undergraduate Research present what is a poster. We have some of the college level administrators come talk about the value of diversity in the academy, and all sorts of different guest speakers that come during the semester. A faculty member from the Institute for Advanced Analytics comes and talks about presentation skills. And so that sort of outsourcing those topics brings in people with real expertise. It helps the students see that we don't necessarily have all the answers ourselves. And it just, I think, really helps them get that rich undergraduate experience that we all want. And so that's everything that I wanted to kind of cover up front. The next slide has some resources that I like on it. And that's it for my class. Thanks.
Well, great, Emily, and thank you very much for kind of setting the stage there. I think you've done a wonderful job in kind of giving us that bigger picture and really justifying why this is important. To me, I'm really excited about this because we've been seeing like dramatic growth in K-12 data science programs. We now have students coming into our undergraduate programs with skills that used to, require a graduate degree. The tools and the data are now allowing us to be kind of going much deeper, much further, much faster with our students. And I think it's pretty exciting. You kind of elucidated the high impact practices. And again, when we think about what makes learning stick, what helps build these capacities we want our students to do, data acumen, however you want to describe it. These kind of experiences really do that. And when we think about kind of the advent of ChatGPT and large language models, there's a superficial level of things that people are going to be able to get, but to kind of get the deepened ways of kind of really extracting meaning from data, they're going to need to be having the kind of programs and structures you put together. One of the big challenges, of course, is going to be aspects of sustainability. How do we make this work? And I love to hearing what you and your co-conspirators have been doing to kind of really build this. And it's that sharing of resources, kind of best practices, approaches. And we also need to figure out how to justify this to our administration. It's going to cost time for people to be able to pull these things together. We're not going to be able to have 150 students having the same kind of experience in smaller ones. But again, it's going to be a really valuable part of our students' introduction education. And I think the work that you've been doing to scaffold this has been great. I'd like to segue ever so slightly into information about the data science core. Next slide, please, Kelly. So this is an NSF funded initiative. There's alphabet soup going on here. So HDR is the Harnessing the Data Revolution, one of the big ideas from the previous administration, but still a really important idea. This funded the data science core, which is a set of projects, including some of the things that Mark has been involved in that we'll be hearing about, that are really intended to kind of help build those capacities and help build the workforce. We have a project that's run through 9 institutions, the 5 colleges in our area, 3 community colleges, and the University of Minnesota, funded by the NSF. There's information about the grant and other things. I'll put the links on there as well. I know we're going to be sharing the slides, but next slide, please. What is the HDR DSC wave doing? As I said, the big idea, there's 2 parts of it. The first part is what I want to talk about today, which is that we're developing structures for undergraduate students to work on data science for social good projects. And so these are going to be scaffolded in various ways so that students kind of engage in these workforce skills that are needed working with local community organizations. So we've had projects with our local bike sharing network, which is really thinking about where their sightings stops to allow their kind of to be supporting historically underrepresented communities, under-supported ones. Girls Inc., kind of a girls empowerment organization, some Nature Conservancy, the Western Math Health Equity Network, and other ones, really kind of thinking about places where there's messy data and a need to kind of bring that together at scale. Next slide, please. So one of the approaches we did for this was to, again, think about the scaffolding. How can we organize things so that our students are involved in helping to make these structures possible? It's not possible for us to have an Emily or a Nick or a Mark in every one of these places at all the times that the students will be doing. And what's more, we really need them to practice these skills as we go. So in a paper that we wrote early on in the project, in the Harvard Data Science Review, we noted that courses and programs are teaching all kinds of neat stuff, call it data literacy, data fluency, data acumen, building these skills. But we can only expect coursework to go so far in a traditional coursework model. Again, we heard from Emily, how can we kind of bring in these high impact practices and kind of have that experiential approach in new courses? But we also wanted to think of that there are other co-curricular approaches to make this possible, because it was pretty clear to us that our previous model of just here's these materials is, and maybe you do a little project, is not going to be enough to give them the experiences with data and computing they need to be successful in tomorrow's workplace. So this paper kind of laid out the rationale for it. And we've now had 4 years experience with the project of how it's been playing out. Next slide, please. So what are Agile and Scrum? These are techniques that have been developed in software engineering. So they're typically used by companies where you might have employees who are working on a particular project, say a release of a large software project. We've taken this idea and mapped it onto data analysis work, and to kind of be taking it from these employees at companies to undergraduate students. So the idea, there's a lot of kind of nomenclature and approach to it, but it's a way of kind of breaking things down into smaller parts and pieces. We think about the idea of these short sprints as a way of kind of breaking up large tasks, taking a large project, bringing it into smaller parts. We have a backlog. These are a list of tasks or issues, priorities that need to be done right now to get us to the next level. We kind of work and develop these team and stakeholder communication structures using things called stand-ups. Stand-up, the idea is you're standing up, the meeting's going to go quickly, but it allows everyone to get the information they need to be moving forward to the next level. Kanban boards, again, provide some technological scaffolding to kind of keep track of the various moving parts, what's needed for this issue and project, who's working on it, and what kind of, what support do they need to move forward. Code review is a really important thing. My experience, and I think many in the audience have had this as well, students don't want to share their code. They're kind of like a little nervous about that process. But we know that kind of other people's comments and thoughts are going to help make that a better process, and kind of getting that level of engagement where students are willing to critique other people's code and also to be to receive that critique is going to get better results later on. Next slide, please. So once we have these things, at the end of a sprint, there are demos where people are kind of sharing what they're doing. Often this involves the client, the stakeholder from the community organization, and then also the idea of thinking about retrospectives. So providing the kind of Deming-like quick feedback and an assessment of how things are going along the way we go through a semester. It might be 4 sprints during a semester-long period, but to kind of think about that continual improvement kinds of approaches. So what I'm really excited about this is that it's not easy, it's not hard. Next slide, please. But we did find some ways that it seemed like this was really helpful in providing a structure that was useful. So there was a quote from our paper that appeared recently in Foundations of Data Science. So the inspiration for DSC Wave was a question about whether undergraduate students could tackle real-world data science problems utilizing kind of modern tools and approaches frequently seen in industry. And based on our experiences, the answer is yes. But next slide, please. Lots of lesson learned here. It felt like we're just at the beginning stages. We know that undergraduate students need this ability to think with data. They need to kind of have the practice in these different ways of understanding and practicing this entire data analysis cycle. But it was still pretty hard for them. And we certainly need places where our courses and programs need to adapt to provide them a higher level of fluency in these kinds of ways to make them effective in a course like Emily's, or to make them effective in this kind of program. And what we found was that these DSC Wave projects have provided a starting point. They still required a lot of work from the faculty sponsors to make it all work, to kind of keep these loose ends in place. But there were some really good signs where we started getting student leadership in that way. And those are, I think, the skills that are going to serve people well in the future. So that, to me, was my overview. As I now kick it over to Mark, I'll put some links in the chat as well. And there's also a link to the resource document. But take it away, Mark.
Mark Daniel Ward. I'm the data mine director here at Purdue. Maybe we go to the next slide. Just want to give a sense of what we're doing in our university and beyond. Like Nick said, we both have a program in the Harnessing the Data Revolution program at NSF I'll mention in a moment, but I want to just give a little overall context. There's a new department in our university called Data Mine that's not in our science college. It's not in the engineering college or the business school. It's in the provost office. And there's 20 of us on this Data Mine team now. So we have a couple homes. We have our coursework and our meetings with students in the residence hall where the students live here at Purdue. And then our offices and meetings are in a business-oriented building called Convergence, where companies also have offices in the same location as we are. I mean, in between our offices, there's offices from companies, so we're really rubbing elbows directly with them. This academic year, we ran 84 different projects with industry partners. We don't require our students to have any background. They are learning about R and Python and SQL and using high-performance computing environment. They're using agile processes with 2-week sprints, very much like what Professor Horton just discussed. They're on teams with students from all kinds of different majors. These aren't just statistics or math or computer science students. They're from the full spectrum of the university. So we had about 1,300 students this year, where I think we've already got 1,700 enrolled for next year. And these students are between their first year of undergraduate all the way up through the doctorate. It's really meant to be the provost initiative for data science for everybody on our campus. It's separate from our data science major, of course. Next slide, please. So just giving a sense of the scale of our corporate partners program, I mentioned we had 84 projects with industry. If you take a look at the companies here, I realize the font is a little bit small and maybe blurry, but I think, again, we're going to share these slides after. We've got partners in every sector of industry, defense, agriculture, national labs, actuarial science, biopharmaceutical science, any area of industry you can imagine. I think we've got some projects, and we've kind of lowered the barrier of entry for how companies have projects with the university. Our legal agreements, very easy to understand. There's no legalese there to really read, like human beings can understand it. It's a very low cost to engage with the university. And we have students from other universities on the projects too, as I'll mention in a moment. I'm going to guess we will have more than 100 projects next year. That's kind of the sort of the rate of growth here. It's the 5th year of our organization having this kind of partnership. Next slide, please. So I should mention a couple different funding initiatives under the umbrella of the data mine. We're so fortunate the ASA is working closely with us on this National Science Foundation project called the National Data Mine Network. It's a grant from the federal government directly to ASA, not to Purdue. My colleague Donna is a co-PI on the project, as is Kathy, our previous president in the ASA. And Monica and Talitha are also co-PIs and contributors on this project. We've just finished our first year of this work. We had 62 undergrads involved, half a dozen graduate students, but we're only funding undergrads on this project. In fact, every dime on this grant goes directly to undergraduate students who are at minority serving institutions all around the country. So there were 27 MSIs represented this year, and then many of their faculty mentors and the students engaged on the same projects our students at Purdue did, and met with mentors in industry every week of the academic year. They were taking on 9-month projects. So we have 123 students already accepted for the upcoming year from minority serving institutions. And we kind of think we have a sort of path to sustainable engagement with our friends all across the country at these schools. So next slide, please. There's another new program we've just started in January under the auspices of NSF's Convergence Accelerator program. That program has traditionally been geared toward startup companies that had something new they wanted to make or produce or invent. And it was the first time they've had a workforce aspect to Convergence Accelerator. And it was geared toward persons from underrepresented populations in the math sciences. So we were excited to have a grant focused on deaf and hard of hearing students. My colleagues, Bonnie Jacob and Carrie Solomon at NTID and at Gallaudet, respectively, are co-PIs on this work. And we've just finished the first semester with 3 teams of students, and we're about to have 4 teams of students for the summer. It's been some of the most enjoyable work I've done in my career. I myself am still a baby in the deaf world, and have been learning to sign the last 5 years, and just really being immersed in the work with these students. So they work in the same modality as the students in National Data Mine Network and the students from the data mine here at Purdue. We just actually had our virtual symposium with both of these groups this last week. That might be the last slide. Maybe there's one more. Yeah, I think that's the last slide. So maybe we hand it back over to our moderators, please.
Thanks. This has just been so fantastic, and I'm looking forward to the conversation. So I want to just encourage folks to have your questions at the ready, because we'll have plenty of time. So I just wanted to take the opportunity to give a shout out for the ASA conferences and meetings that may not be on your radar as good places for students to present. I would say that all of the meetings have a renewed interest in supporting student presentations, but especially the smaller meetings. And so by the smaller meetings, I of course mean the Women in Statistics and Data Science Conference, the Symposium on Data Science and Statistics, and the Conference on Statistical Practice, CSP. And I'll highlight those because those are annual. ISIS is actually in 2024, it's going to be in Scotland. So, you know, just saying, might not be a bad place to have to be a faculty advisor. And then the health policy conference happens every other year. And then of course, JSM. And although it can be challenging for the timing of submissions can be challenging, we are really interested in working with and supporting undergraduates. So, you know, reach out to me. Let's talk if there's some interest in being able to like submit a placeholder abstract. You know, I would love to have enough student presentations at these smaller meetings so that we could have a student only poster session and really encourage sponsorship so we could give some awards. So happy to engage in that conversation today, but also please reach out to me with your ideas. And I'll just leave you with one other idea that with colleagues that we've been kicking around, and that is I had the opportunity to attend the virtual symposium earlier this week, and although not the same I get as in person, really provides a nice opportunity for folks to share their work and eliminates all of the challenges associated with travel and the other expenses of conferences. And so I'm super interested in seeing how the ASA can be more supportive of undergraduate, especially symposia. And so if you have ideas, please do reach out. And I guess with that, we are ready for questions, although I will highlight that this is the second one of the workshops that Kelly and I have organized. And so we are collecting a really nice repository of resources to which we will add the slides and the resources. Some of the resources discussed today are already in the repository, but so the slides and the recording will be available, and that's the link, and that is the QR code as well.
All right, so yeah, now it seems like a great time to open it up for questions from the audience. And I say, pick your poison. If you want to use the raise your hand feature and ask your question, that's great. If you're saying, I can't remember how to use the raise your hand feature, if you want to turn your camera on and raise your hand, that works. If you want to type your question to the chat, that also works. Or we'd love to now just have a discussion and talk about whatever questions you have. As folks are thinking about questions, I'll start with a question that I have. So I liked this, and I'm gonna, stop sharing my screen so we can see each other a little bit better. So I liked Emily's point of prioritizing students who haven't had an experience before. And so I'm gonna pose my question to you, Emily, of like, one challenge I find is getting students to see the value and like want to participate in these type of experiences, right? A thing I'll notice among students who say like, well, I don't want to be an academic. Why would I do that? That's not helpful to me. Like, how do you attract a diverse group of students to this course?
Yeah, that's a great question. And it was harder when we first started teaching it. But now that we've been teaching it for a while, there's some word of mouth where they're like, this was actually really useful when I interviewed. So we get that a lot with, especially with the actually, which I appreciate. And so this actually helped my friend get a job, or this actually, you know, whatever. And so they're kind of talking among themselves now, which has made my job easier. But it's hard. And that's, I will say that's part of why we talk about, you know, the skills that you're building in this, how you can talk about them in job interviews, like what kinds of things employers are looking for. Because most of our students don't go to grad school. They get jobs with a bachelor's degree, and they can still use, you know, their organization skills and their presentation skills and stuff like that in those jobs.
I'll just jump in there on top of that, because I think it's really important to try to think about ways of providing that support early on. You know, it's not like people need one internship and suddenly they're all set. It's that kind of repeated exposure. And people are now starting to do that, as I said earlier, you know, in high school, and having these substantive experiences. There's a related thing. There's a paper, again, in the shameless plug to the ASA published Journal of Statistics and Data Science Education, no paywall. But I put a link in the chat to a paper by Dalzell and Evans that talked about how they'd structured a little partial credit course to help students prepare for DataFest. DataFest is perhaps the best way of kind of the ASA DataFest of preparing for a job interview. It kind of gives you that ability to kind of practice those skills. But I think the same thing is true for internships. Are there co-curricular partial credit courses, kind of structures where undergraduate students could be helping mentor other undergraduates to give them that heads up, so they'll be able to get the internship, so they'll be more effective in them. And I think that's a kind of a great area for us to be thinking about, is how to be supporting students from a continuum. We need to make sure that there's a diversity of students who are able to kind of get these internships and succeed with them.
Yeah, really great points.
So Kelly, there are a couple of questions in the chat, and I'm going to start at the end and work my way up. But one is for a person just starting a data science, to be involved in a data science major, if there was a conference that you all would recommend to a person beginning this journey, which conference, how do you choose which one, what would be the most high impact?
Okay, so Women in Statistics and Data Science is my favorite conference, just because everybody is so nice. Not that they're not nice at other conferences. It's a different kind of nice. So if you want to meet people to talk to them, I would say that. But then JSM has everything, right? So I think it depends on your goals for the conference. If that doesn't help, but I would, or CSP would be another one where I think there would be a lot of topical stuff, but maybe those three.
Probably my main goal is to hear people talk about teaching data science and what's working for their undergraduates. And we're a very small institution, and so, you know, everyone is trying to do 5 different things, and it's really stressful. So like in computer science, I love going to the computer science education, you know, conference, the teaching conference every year. And I was just curious if there's something similar. I think the Women in Statistics and Data Science sounds amazing. When does that conference take place?
Will be October 24th or 25th. This in Bellevue, Washington. So it's usually in the fall. But I would also say, I mean, I'll give a shout out for the symposium on statistics and on data science and statistics, SDSS, as we lovingly use acronyms around here, which is usually in the spring. It will be, actually, it's in a couple of weeks in St. Louis this year, but it has a pretty strong education track. So I, you know, I would have to deny this but I agree with Emily, WSDS is just my favorite, but SDSS and CSP had definitely have that small conference vibe.
And
So
just to build off of what Donna's saying, I think SDSS can attract a little more of the computer science community to it. So if you're trying to find one conference that has a little more of the melding of statistics and computer science, SDSS is really trying to do that. It's still more statisticians for sure, but it's trying to be a little bit more at the intersection. And so, yeah, I guess, if you want that one conference, that could be one that's trying to be a little more of a hybrid.
I am getting the impression that I should join the American Statistical Association.
oh, 100%,
Yeah,
no doubt.
And
Barbara,
then I'll be
we-
in the loop.
We'd love to have you. I wonder if I could kind of hop back to a question that Henry has added into
Yep, I was just
the chat.
pleased. Yep.
And so the question was, what do you think is the minimum time required for a meaningful project for undergrads? And they stated that they've tried implementing mini projects as a culminating part of a undergrad 400 level data science course, capstone like course. And I'm trying to do the best I can with a somewhat narrow time window over the final 6 weeks of a semester, and appreciate any thought, advice, or insight. And again, there was I think the answer to this is there are different ways to be doing different things. What the data mine has done, and I think you get from having a 9-month-long project, lets you go deeper and to kind of build more of those skills. And you described this, Henry, as already a mini project with 6 weeks, where I think there could be some level of iteration of the type of kind of scrum work and things that we're talking about. I think it kind of, for me, going a little bit deeper and a little bit longer to kind of give people different opportunities to be in different roles throughout a project, to kind of have the opportunity for, to meet with a community partner if you have one, or a data provider, and to have a couple of those meetings alone to kind of give that sense of how things are coming together. I think we all find that the end of the semester, end of the quarter is crazy, that just all time disappears. So that's also a challenge of kind of tagging this on. So this is where I think setting up these courses that provide some of those opportunities that might complement or augment what we have in various places would be my answer. But I think having a 6-week project is better than nothing, because I think people need lots of these opportunities, individual and in groups.
Kelly, I think we have a hand up. So Ranjani, go ahead, please.
Hi, yeah, I'm Ranjani Grove, and I'm at University of Washington, and I have actually 2 questions. So one is a short one, I think, for Emily. So Emily, you mentioned that you have your students working on student data, and at least at the University of Washington, I mean, that would be practically impossible for us to get our hands on. And I just wish we could, because it seems so meaningful for the students to work on data about themselves. So I'm just wondering if you could talk a little bit about the process for getting access to that kind of data at your university.
Sure. So we definitely had a leg up because my co-instructor used to work in the Division of Academic and Student Affairs. And so she worked with those. And when we first started, we had just a little undergrad research lab. So we had 2 to 6 students a year. And they had to work in a specific computer lab because even though they were blinded, the data were very confidential. So over the years, as it has not gone badly, we have slightly less information, so fewer variables. Everything is blinded. So we change or substitute out and sometimes permute a little bit, like gender and URM status and things like that. But the students also have to sign a data confidentiality form and leave it on a shared drive. And that is an academic integrity violation if they violate that. And we work with them really carefully on how to talk about the data and how to put things in context in ways that won't harm like underrepresented groups or sort of historically marginalized groups that maybe are showing slightly less academic success in some areas, but for reasons that could be explained very easily if you think about sort of context, history, things like that. And so we spend a lot of time working with them very carefully on that. And then over the years, because we've been doing this now for 9 years, have been able to build up a level of trust. But it's hard at first to get data like that, because I think a lot of our campus partners have been burned before by sharing data, and then somebody draws a conclusion with it that maybe isn't quite fair, you know, or something, and they lose control of the message.
Yeah, thank you for that. I also had another question, which is on our campus, the focus really of the provost has been on pedagogy and on fundamentally changing how we teach and more learner-centered approaches and so on. And I think projects naturally they seem very much to touch on those kinds of things. And I was hoping that maybe I could ask you guys to talk a little bit about sort of the pedagogical approaches that you have used in these project-based classes.
I'm looking at Nick.
So thanks, Emily. I think there's lots of places where we can think about our pedagogy as we move forward in some of these areas. I'm a big fan of the Dana Center guidelines on, as we think about teaching data science, how we make sure that we're using inclusive principles in terms of that. There's been a lot of work on other initiatives. I'm tangentially involved in the Being Human in STEM initiative, which is started at Amherst, Yale, and other places. But yes, I think when we look at those other high impact practices that Emily was reinforcing and mentioning early on, that the internships are just one of those. And I think there's lots of ways where we can be thinking about developing those principles and approaches and to kind of help students kind of get that deeper understanding. I think one of the challenges here is that this is very different from a model where there's a single person and 4 graduate students and 400 students, and there's 2 midterms and a final exam. And I think this kind of question, Emily talked about it a little bit, of kind of finding these projects is not easy. Kind of helping to kind of coordinate and support that requires a level of staffing and support that has not always been there. And I think we need to figure out mechanisms. I'd be particularly curious about Mark's sense on this, in that, is this just above and beyond as part of our jobs? Are we, what part of our job is this kind of maintaining and nurturing these programs? I'm really proud that the data mine funds are going to the students, but I'm also kind of wondering, where is the time coming? Because again, the faculty, the staff support for this has not always historically been there. Provosts have said they want inclusive practices, they want modern pedagogies, active learning, and other kinds of approaches, but are there the supports and resources to make that happen? When we realize that people with statistics and data science skills can get jobs doing all kinds of things. And so there's a kind of a demand for the people teaching it. So again, I think these are some of the challenges that I'm seeing on my end. But again, Emily, Mark, I appreciate any of the thoughts you might have.
I could weigh in on what Nick said. Our model is, everything in our team is self-funded, and there's 20 of us on our staff. It's just a testament to how much need there is in industry for students who do have good project experience, regardless of what the major on their degree says. They're going to have interdisciplinary experiences when they get out. So whether or not a provost or a dean, funds it, and whether or not it's in our call as faculty, for how we structure our learning and our teaching and so on. There's an appetite, I think, for these experiences, both from students and from industry, and it's simply a matter of, do you want to continue having the regular kind of statistics curricula so many departments offer, or allow our colleagues in industry to play some kind of leading role. I'm really of the belief now that it's impossible for us as faculty to keep up in terms of the curricula and keep our data science offerings modern. I think just things are changing too fast for the curricula. We all know curricula is so slow to change. And I know there's fundamentals and principles that every human ought to know coming out of college and grad school, but wowie, it's hard to compete with having that real world experience. So we just kind of follow the lead of whatever our colleagues in industry want to do and then assume we've done due diligence. Yeah.
I'd point to one thing that Emily said though about providing a lot of structure, like even that point that Emily made about having the teams sign like an agreement of like, here are the responsibilities, I think is speaking to still pedagogy, good pedagogy, right? Like really being very transparent when they're having an experience that's so different from a more lecture-based experience of what is expected of them, what and you know, Emily said very explicitly laying out what they're going to get out of it, but also just what they need to do for the team, I think is a really important part of that process, because the students don't necessarily know how to be an effective, you know, member of a team. So being very transparent, I think is part of that.
So I just want to, I was going to hope that maybe Emily, that you would talk about what you said you were doing with potentially doing with your intro class in the fall in terms of authentic assessment, because I do think the opportunities to do different kinds of assessment, but that are more authentic, kind of speaks to the sort of boots on the ground classroom pedagogy. So
Yeah, I teach Python, which is hilarious if you knew me growing up. I almost failed computer programming in college, and I was like, well, I'm glad I'm going to be a statistician and I'm never going to need to know this. And now I'm teaching coding, and my brother's an IT guy, and I texted him a picture of the textbook when I got it, and he was like, what is happening? And I was like, people change. But anyway, so I'm teaching this coding class, and the students do really well, but it's not, I don't know that they all have fun doing it. And so I added a project. It's not even a project. I added an in-class like fun day in the fall, where I gave them some clean data from different websites, and they had to just come up with a question and make a plot that answered, or not answered, addressed the question in an appropriate graphic, right? So like if it's a scatter plot is reasonable, then it's a scatter plot. But if a scatter plot is not reasonable, then don't make one, right? Which is harder than it might sound. And so then this semester, I expanded it to a homework assignment. So they had a week to do it, and they had to write what they learned. And they love it so much. And I was at an open house for sciences, and was next to our state climate office on the table displays. And we got talking, and they get all these random questions via email during the year about like, well, it's rained 16 of the 18 Saturdays this year. And so people email and are like, is this normal? Is it rainier on Saturdays than other days of the week? And so we're going to meet this summer, and they're going to collect some of these questions. And the students' last homework in the fall is going to be to answer one of those questions and then write a blog post about it. And if it's a reasonable one, then it might go on the state climate office blog, which is so exciting. And the students love and hate real data. So my favorite quote about it was in a class evaluation, somebody said, wow, real data are really annoying. And they are, right? But that's also the fun part. And so I'm really excited to be able to build like little pieces of that into this, where they can start thinking like, well, how would I show if it's rainier on Saturdays than it is on other days, right? Like what's a reasonable way to think about that? And then all that stuff, it sounds so easy, and then it's actually pretty hard, right? Because do you compare it to like all the other days? Do you average the other days? Do you look at the whole weekend, right? And all those decisions, and they're going to have to make all of those decisions. And so I'm pumped about this. And then it's just going to be like a regular 10-point homework assignment. But then maybe they'll have something to like email their parents, right, to show them what they did in college.
I think that's a great approach, Emily, and it really gives me some really good ideas about thinking how to kind of make some of those things happen. I just wanted to pick up one of the other kind of comments that came in the chat. Again, thank you, Henry and Mark, about this idea of where to see places for graduate students to participate in these kinds of undergraduate projects. And Mark answered that, you know, at the Datamine, they've set things up with undergraduates, masters, and PhD students on the same team, but the leader is always an undergraduate student, which I think is a really important agency thing. I have had conversations with folks, Rebecca Nugent in particular at Carnegie Mellon, about how they've often arranged things to be to kind of incentivize and provide support for graduate students to be involved in initiatives similar to Datamine that they're doing. And they've figured out little ways of a little bit of magic, you know, discretionary funds that can be going towards conference travel or other things. And a little bit of money for graduate students can often go a long way. They want to do it, they're interested in doing it, but this gives them an initial kind of little bump and boost. And I think that's going to be a really helpful way to kind of get people involved on some of these initiatives, because it does take, you know, kind of back to Emily's set of the co-conspirators and Mark's small but dedicated team that's pulling off this thing at scale. We need to be able to figure out ways of supporting those individuals so it's sustainable for the longer term.
Wow. This has been great. And we have about a minute left. So any final thoughts from the panelists?
Go try it. Like, put a project in one of your classes. I mean, it can be just an in-class fun day if you're worried about it. That is definitely how I started, because I was like, I do not know. And we spent most of the first day just trying to get the reading and the data working, because the weather data had an S after one of the numbers in row 400. It turned out, right? And yeah, so there you go. But so then we just took another day to make the plots. Yeah, but just do it.
Perfect message. And we will. So thanks again to all our panelists. And I need to say thank you to my co-conspirator, Kelly McConville, because this would not have happened without her, for sure. And we will we have this great repository that we're growing, and we will post the slides and stuff that's been shared. And I would welcome you to help us add to it. So feel free to reach out with suggestions, and we'll keep growing.
Yeah, thanks everyone for coming and taking time out of your very busy schedule, grading finals or
Right.
finishing up your quarters, all that jazz.
No, yes.